like the top 25%, the lower 25%. That's when they're using a box and whisker. So a box and whisker plot is a data display, so a way to display data, just like a bar graph is a way to display data, a line graph, a frequency table, all different ways to display data, that organizes data values into 4 groups. And the nice thing about those 4 groups is it separates them into 25%. So just know that each group that we see is going to be an additional 25%. Everybody with me? A box and whisker uses one mathematical operation, and it's finding the median. We're basically finding the median with a group, and then with a different group, then with a different group. And remember, the median is just the number in the middle. So, the lower quartile, which is typically referred to as LQ, just a short version, is the median of the lower half. So we're going to find the median of all the data, then we're going to find the median of the lower half, and then we'll also find the upper quartile, which is the median of the upper half. So basically, you're going to be finding the median over and over and over again. But hey, at least it's not the mean. The lower extreme is a fancy word for the lowest data value. And the upper extreme is the greatest data value. You have to have all 4 of those things to construct a box and whisker. Everybody with me so far? Questions, concerns?
Are the lower extreme LE?
They actually don't do that very often. You could though, but you're not going to see it very often, like mathematically. But you could. Okay, so let's just dive right into it because it's easier the more we do it. So these are the 6 steps. If you can do all 6 of these steps, you're going to do just fine. All right, so create a box and whisker plot using the data. Your first step always should be when working with data is order your data from least to greatest. So right now, spend about 30 seconds and order your data from least to greatest. Okay, so we have listed our data from order from least to greatest. Is everybody good with that? No confusion there? Okay, second step. All you're going to do is find the median of your data. This is what I don't want you to do because it can make it really hard in the future. Don't scribble them out. Because if you do that, you're not going to be able to find the upper and the lower. So all I do is I just check them off. So I'm trying to find the median, the number in the middle. But I get 2 numbers in the middle. If I get 2 numbers in the middle, what do I have to do with those? Croce?
You add both the numbers and divide by 2.
Yeah, so 7 plus 12 is 19. 19 divided by 2 is 9.5. So your median here is 9.5. All right, here we go. So once you found the median, you then are going to do that to find the upper and the lower quartile. So this is really simple. You want to take for the upper quartile, you are taking all numbers greater than the median. So if the median is 9.5, I'm taking all the numbers greater than 9.5. Everybody with me? Upper quartile, so that's the numbers greater than 9.5. And then I'm just finding the median of those. And now you can cross them out. So I'm left with 2 numbers again. 13 plus 17 is 30. 30 divided by 2 is 15. So my upper quartile is 15. It's just the median of the upper numbers. Everybody with me there? Okay. Now for lower quartile, you do the same thing. So all the numbers less than 9.5. Oh, and they're both 6, which is nice. So my lower quartile is just 6. Questions on how I did that? Anybody? Awesome. All right. So we've done step 1, step 2, step 3. Step 4 is super easy. The upper extreme is just 19, the greatest number. That's it. The lower extreme is 5. That's all that means. means. It's just a fancy word for the greatest number and the smallest number. Everybody good? So we've done step 4. All right. Here comes probably the most confusing, except the easiest at the same time. All right. So we're going to plot the median, quartile, and extremes above the number line. So here's our number line. Sometimes you can count by 1, sometimes you can count by 2s. I'm going to count by 1s for this situation because there's not many numbers in between. But sometimes you may have to count by 2s or 5s or whatever. So I'm literally just going to I'm going to start at 5. 5, 6, 7. Just the number line. I'm just counting. As should you. And you don't even have to use the whole number line because we only need to get to 19. If you go a little bit farther, that's fine too. Everybody good? Okay. Now, one weird thing is you're plotting above the number line when you make things. You don't want it to be and all that. You just want it to be showing the data. We don't want it to actually be on the number line. All right. So, first thing I always plot is my upper extreme and my lower extreme. And those are just going to put a dot. So I'm going to go to 5, a little bit above 5, put a dot. And then I'm going to go to 19, a little bit above 19, and put a dot. Just like so. Everybody good so far? Those are going to make what we call the whiskers. Now I'm going to make my box. My box is just the upper and the lower quartile. So I go to the upper, which is 15, and I put a line. Now it's not going to be perfect. Then I go to my lower, which is 6, and I put a line. And then I'm just going to connect them to make a box. And then in the middle of my box, I'm going to put the median. So 9.5, I'm going to draw a line. And then to create whiskers, I literally just connect. Whoop. That's it. So I'm going to label just for you all. This is lower extreme, lower quartile, median, upper quartile, upper extreme. And if you've noticed, it's into 4 different sections, right? So this is 25% of our data. This is 25%. This is 25%. And this is 25%. Very cool stuff. So let's act like this was time it takes our class to run a mile, let's just say. So this is 5 minutes to 19 minutes. That's a fair range, right? Some people may be walking the mile, which is fine. Some people may be killing it, okay? So let's just say this is a range, okay? So where does the middle 50% of our class run the mile? What's the middle 50% run the mile? The middle 50%. So where would we find the middle 50%? What would represent that in our box and whisker? No, that's the middle of our class. We want to know the middle 50%. Where is the middle 50% in this data? Uma. Right, the box. The box is your middle 50%, right? So the middle 50% of our class can run in between 6 minutes and 15 minutes, right? That's the middle 50%. What's the lower 50%, or the people who run it the fastest?
5 to 6 minutes.
5 to 6 minutes. There's not many people there, right? Which would make sense. But there is our upper 50% range from 9.5 to 19 minutes. So they're spreading out more people here, right? Which would make sense, because not many people are going to be on this lower end. But not many people are going to be running it that quick. Does that make sense?
Yeah.
Everybody understand that? All right. Let's answer these couple questions on the back then. We already kind of did. The top 50% fall in between which 2 numbers? The top 50% fall in between what 2 numbers? Look at your data. Where's the top 50%? Truett. 6 and 15. 6. That's the middle 50%. We want the top 50%. So from 9.5 to what, Drew?
15?
Top 50. So this and this. Top 50 would be this and this.
Oh, 19.
Yes, perfect. So 9.5 to 19. All right. The middle 50 we already said was 6 to what? 15. How many numbers are there in the bottom of the data? Well, Clay already told us that. Just 2. 5 and 6. So that's the nice thing about Box and Whiskers. They split up your data into those 50%. Everybody good? Questions, concerns? Okay, so now what you're going to do, you are